All right, let's jump right in and try to peel back the curtain on what is, without a doubt, one of the most game-changing technologies out there right now, large language models. You know them as LLMs.
So let's get right to it. This is the big question, right? I mean, you've probably used them a dozen times today already to write an email, search for something, maybe even write some code. But what is a large language model, really? Okay, so to really wrap our heads around this, we got to start with a solid definition. What are we actually talking about when we say LLM?
Okay, so strip away all the hype and here's what you've got. An LLM is basically a giant prediction machine. Seriously, it's a massive digital brain that's been fed a library's worth of text, learning all the patterns, the grammar, the weird quirks of human language. And its entire job, its one core function, is to guess the next word in a sentence. Sounds simple, right? But that one little trick is the key to everything.
All right, so if it's just a prediction engine, how in the world do you build one? It's not some kind of dark art or magic. It's more like a recipe, a really, really expensive and complicated recipe.
So this recipe has three main ingredients. First, you need the blueprint, and that's something called the transformer architecture. It's this brilliant idea from 2017 that lets the model figure out which words in a sentence are the most important. Next, you need the cookbook, except this cookbook is basically the entire internet. We're talking a colossal amount of text. And third, you need an oven, an insanely powerful one. We're talking about massive computing power running nonstop for weeks, sometimes even months, just to process all that data.
And about that last step, the learning part, let's just say it's not cheap. To give you a little perspective here, check out this number. When Google trained just one of its models back in 2022, the price tag for that single training session was an estimated $8 million. That's the kind of mind-blowing scale we're talking about.
But wait, there's a crucial step before any of that learning can happen. You see, computers don't speak English, they speak math. So you have to translate all that text from the internet into numbers. This process is called tokenization. It basically chops up words into little numerical pieces. So a word like tokenizer might get split into T, O, Ns, and each of those bits gets a number. That is the language the AI actually thinks in.
Okay, so you've got the blueprint, the giant library of text, the insane computing power, and this is where things get really, really weird and kind of cool. When you put all those pieces together at this enormous scale, something totally unexpected happens. The model starts doing things it was never programmed to do.
They're called emergent abilities. It's like one day it's just predicting words, and the next, poof, it can solve complex math problems. It can unscramble jumbled words. It can even show its work, reasoning through a problem step by step in what researchers call a chain of thought. It's a huge leap from just guessing the or a. It starts to look a whole lot like actual understanding.
And this has led some folks in the field to talk about these things as, well, almost like an alien intelligence. I love this quote here. The idea is that the raw AI is this weird, inscrutable Shoggoth, a creature from H.P. Lovecraft, by the way, and all the safety training we do just slaps a smiling facade on top of it. It's a pretty wild way to think about it, right? That underneath the helpful assistance is something fundamentally not human.
But, with great power comes, well, a lot of problems. This incredible technology has a flip side, and it's full of some really tricky paradoxes.
And this is the biggest one. This is crazy paradox. The exact same model that can write you a sonnet that would make Shakespeare jealous can also, in the next breath, confidently tell you that elephants can fly. It just makes stuff up. This is what we call hallucination. And honestly, it's one of the biggest headaches for everyone working on this stuff.
And here's the thing you absolutely have to remember. Since these models learn from us, from our writing on the internet, they also learn our garbage. The LLM is like a giant mirror held up to humanity. It reflects our biases on race and gender. It picks up our political squabbles. It even learns to be a sycophant, just agreeing with whatever you say because it learned that makes users happy. It reflects the good, the bad, and the very, very ugly.
So where does this all go from here? Well, despite all these problems, the next chapter is being written right now, and the speed is just staggering.
I mean, just look at this. The core idea, the transformer, only came out in 2017. 5 years later, boom, ChatGPT is a household name. And now, barely a couple of years after that, we're seeing the first models designed specifically to reason. The pace here is just insane. It makes everything else in tech look like it's standing still.
And this is the new frontier, reasoning models. This is a total game changer. We're shifting from models that just guess the next word to models that actually generate a long chain of thought. They think step by step, internally, before giving you an answer. And that simple change is leading to absolutely dramatic improvements in things like logic puzzles, complex math, and coding.
Which leaves us with this final, really important question. These models are quickly becoming the architects of our digital reality. They're not just fun toys anymore, they're foundational. So the real question isn't about what they can do, it's about how we are going to guide their evolution. Are we actually prepared for that responsibility?